Assume you have a dictionary, right? So you were to search a word, what do? You don't exactly know which page this particular word exists, right? So that's why you probably choose the middle page of the book. Maybe not exactly middle, but somewhere in the middle. Okay, and then you see probably it's let's say H or M or whatever the letter is. Let's say it's something like this. Okay, and you get this. And now let's say your target was the target word was, let's say, a chair. Well, in that case, you would have to move leftwards. Again, you don't really know if the chair word could exist in the starting pages or in this one. So you still have an estimate that it probably exists somewhere in the middle, and then you're gonna make an assumption. So let's say you do get over here, so you get maybe an ear or somewhere with E, and then you can make a another assumption from here between this one. C related items. Again, you might have to do for the second letter, the third letter, and the fourth letter, and so on. Again, if the word on the other side was, this was the first iteration that we did, but if the word was on the right hand side, let's say if it was something with pottery, if the word was pottery, right? Then you definitely would have to split the right side of the book into half, right? So you'd have to go from the middle to the end. And in this case, it would have been from the start to the middle. So, right, you're basically splitting this into half. Notice how you're actually not turning every single page this time, but rather dividing this into half and then trying to get through your target element. If your target element or target sort of page is reached, and that's where your goal is reached. Now, let's get with the understanding of how can we do this in an array, which is sorted, which is something like this. How do you get find your target element without actually having to do a number of searches, rather lesser number of searches? Let's say if I could find the mid element of these elements, mid element of these elements, and that would have been, okay, let's say I go with the indices. Okay, I go with 0 plus 5, which is the start. Okay, let's just take it over here. So if I were to go 0 plus 5, that's 5, and then divide by that 2, and then 2, and then I can go, let's say it's 2.5, but let's say I go with this index, and then let's say this is the middle element, and then I can split this sort of thing into two halves. Okay, two halves, or this one, right? Sorry, it should have been this one. So I get a new start and end this thing. So I know that the element can exist somewhere in between these things, in these ranges, right? And then you can split the thing into half, and then you might actually find your desired element. Then I might good for the right hand. So now let's go with the code implementation of it and also try to understand, let's go with the pseudocode understanding of how things can work with binary search, right? Okay, so we'll have, in a binary search, usually we'll have these three scenarios. So when you consider the start element and the end element, and then you try to find the mid element, and then you check if that is equivalent to your target. Let's say in a dictionary, then you open M and then you open mango. Okay, that's probably the 13th element in an alphabet, right? So I'm just guessing that mango is going to be the middlemost element page. So in this manner, if you were to consider this particular array, if you were to find the middle element, so that is 4 index with a value of 12, right? So you found your target and you get your target, it's found. But now let's say your target was 8, okay? So you find the middle element, which is 4 with its index. How do you find the middle element? In case if you're wondering, you go with the start index, okay? This index, plus the index, which is 9, minus the start index divided by 2. So you can also do something like you can just add both of these numbers. You can say 0 plus 9 divided by 2, and then you get 4.5, and then you were to just round it off to getting 4. Although this sounds correct, this isn't the appropriate way to go about finding the mid element. Although you actually get the same result, which wouldn't be the case in certain scenarios, which is why we wouldn't go about using this formula, which I'll talk about a bit later. But just assume that it's the start plus the end divided by 2, but we're now going to use that formula in when you're writing in code. So in this case, the element that you find, your target element is lesser than the middle element. So that means we'll have to go towards the left. So this high pointer that you found, the high pointer, which was over here, you're gonna move one step minus the mid pointer, right? That means your high is gonna be mid minus 1. So if I were to, not quite sure how this thing works, but let's say then I were to just move here. So that means the high would be, or the end would be mid minus 1. Well, in this case, you found the element, and then you do binary search, and then you try to find where your element is. Okay, let's assume this element was 7. Okay, because you do have to find your element. And now, in this case, let's assume that the element that you wanted to find was 21. Okay, so you would have to go right. Okay, so in this case, again, so you would have to make your start index equal to mid plus 1, which would be over here. Okay, so this would be your start index, and this would be your end index, and then you find the middle element, which is your 21, and then eventually you would go about getting it. So notice the number of iterations that I made this time. So I made one iteration in finding this number, so that was just 1, and another iteration to just find this. And let's just say it was 23. I would have made one more iteration by adding this and then saying this thing. So 3 for finding this instead of going 8 times linearly one by one. Okay, if you would, I know this sounds very less number of compute wastage compared to just 5 wastage by doing this operation, but it's actually a lot when you consider the n value to be really long, okay, or high or whatever, right? Now let's say you had so the time complexity of this, we're gonna talk about that a little later. But now we're going to try to code this thing up and then try to find the complexity and how it actually matches with a large numbers and how this thing can actually save a large amount of time and time basically, yeah. So let's start coding this thing up, okay? So what do we have? We need an array like this, okay? This is just for understanding. Okay, I was just wondering why it's so hot pink. The color that I chose wasn't red, it was pink. And let's go with 2, 4, 6, 8, 12. Okay, the simplest way you can think of it. And then 0, 1, 2, 3, 4, and then yes, pretty much. And now we're gonna write the code for it, right? And I'm gonna try to write this in a pseudocode format. Pseudocode, right? Which color should I choose? Let's go with this one. So func or whatever binary search. And what do I need? I need an array, okay? And I'm gonna choose an array as an input. I need the length of the array, although I can find it by finding the length of the array by doing dot length. And I need the target element, right? I guess that's it, right? You don't really need anything fancier. So I don't think you need anything else, but even this n would probably be quite unnecessary. So an array and a target is what I would say is pretty important. So now you can find the length of the array by doing dot length or size or whatever whatever language that you're using, and then you can just put up a while loop, okay? And then you can set a low variable to be 0, which is going to be the starting index, and high to be equivalent to length of this thing minus 1, actually, because you know, if you've seen the previous video, the length of this thing is 5. Since we start from 0, it's usually a number less than the last index. Sorry, less the last index's position is usually the one number less than the total size of it. So if I were to find the last index's number, that is going to be the size of the particular array minus 1, because we start from 0, right? To take a negative, take account lesser than the maximum index position, whatever, you know? So as long as the low is lesser than or equal to the high, okay? So this is low and this is the high. As long as the low is lesser than the high, I'm going to go about creating a while loop. I'm going to find the mid element, which is going to be low plus, I mean, as I said, you can do low plus high divided by 2. That is cool, but it's not going to work. Why it's not going to work, I'm probably going to explain that a bit later. Okay, well, actually, I am going to explain it now. So this is the most better formula than this, okay? And then you have to find the nearest element to the left-hand side, where you get it. So you can probably find a floor value of this and then try to get things done, but this is not the most appropriate way to do it. So the reason being, when you add two integers in computer science, so there's a chance of, okay, in your book, when you add two integers, it's completely fine, okay? You add thousands, you add trillion, you have Elon Musk, and then if you were to find the net worth of Elon Musk, and then Zuckerberg, maybe trillion, and then 2 trillion, it's completely fine. You can have any number of zeros on your booklet. However, in computers, there is a limit to certain data types. Okay, I'm not saying that it's impossible to compute large numbers at all. But when you consider something like integer, which is what you're going to use to find this thing, okay? So when you find that, there's a certain limit to you can actually go about adding them to. So if this number was exceeded, so there's a chance that the integer overflows and actually goes to the negative side of it. So I'll just give you an example. Let's say the limit of this was 5 and I added 2 plus 3. There's a chance of it overflowing and actually going to minus 1, right? Because it overflew the limit of 5 and it went to minus 1. So this is not something that we wanted. And there's a chance that it would happen in this case because when I add low plus high, let's say both of those numbers are enormously high. But when I divide it by 2, it's already become negative, right? And dividing by 2 just makes our equation just completely irrelevant. But in this case, low, it's probably somewhere around 3, okay, or 2, which is in the limits, and this also would be in the limits, and this is also within the limits. So if I were to just subtract both of these things and also divide them by 2, and then if I were to add, it surely has to be, I mean, not, it's usually under the limits, right? Because it's not overflowing because if you know that the high itself is lesser than the limit, so then definitely this thing, the addition of both of these things would be under the limit, right? I mean, you can just do trial and error, and then you'll try to figure things out, and that's where you make mistakes, and that's where you learn and understand a lot of things, right? So I had that problem, and then I figured it out, and so you find the mid value, okay? enough of me yapping. And then I'm going to check if the target, uh, if the array of this one, okay, this is the array, um, the target, I'm going to write the color target is equal, right? Sorry, the mid, sorry, because we're indexing is equal to the target, right? Then you can say, you can just return this particular thing. You can just return the index where this sort of thing lies, right? I'm gonna return mid. That is gonna be my index where the target lies. Else, I can put an else loop, right? I can put an else loop and say if the array of mid, okay, if the mid element, which is in this case, right? If the mid element, which is 12, is greater, okay, greater than this one. So this was what, greater than the target element. Let's say the target element was 7, then we would have to move left, right? So you can just draw an array and then you don't have to remember everything. If this was greater than the target element, right? You can, that means that it's pretty great. That means this has got to be the end, right? So what you're gonna do is you're gonna move the end, okay, which was set to the this one. This is the high, sorry. So this was set to array of dot length minus 1. So this is what was set currently, and the end is gonna be mid minus 1 because we're moving to the left, right? And now this is else if, okay, where you can put another if statement if that is not true and if this is true. And again, now another else if, okay, you could put an else statement, but there could be another type of answer. So I'm just gonna go with else if the array of mid is greater, sorry, is lesser than the target. So what does this mean? The target is greater than this one. So that means it's definitely towards the right hand side of the array because the target is on the right of the middle element that we're currently on. So notice that each time I'm actually indexing the mid because mid is just an index and target is the number. So mid is the index and target is the number. So the target is on the right hand side of the current mid element that we are on. So we'll have to move the start of the index, okay? Start of the index from here, okay? From here to here. If this was the mid. If this was the mid, and then we're going to move from here to here. So we'll get an equation like this. The start is equal to, okay, I'm sorry, I'm confusing you guys with uh these things. I've used low, mid, sorry, low, high thing. So I'm just gonna use just one of those things, right? I'm gonna use start and okay, and here as well. Start is lesser than e. I'll have to change a lot of things. End minus start. Okay, is there any other place where I would have to change? Okay, so now I'm gonna make start equal to mid plus 1, right? So, and now I can put another else condition, okay? This would be not required actually. So we'll see. So the other type of condition that could possibly arise uh, is that the element does not exist, right? So that would be true if it were to come out of the array, right? In the first place. I would say it just maybe you can okay. We'll think about that. Okay, so that type of condition. So we're now gonna go with take a break. Okay, as the thing is, in a function when you return something, okay, this one we're actually returning mid, right? So this is the return type has become integer right now. So integer becomes the return type. So if this were to exit the array, despite following these conditions while loop, finding the mid element, and then trying to see if the target matches, trying to see if there's an else condition where if this things happen. And even then, even all of this, the word to just come out of the while loop because the start is the condition, right? And if this were to exceed, let's say the start was greater than the end index, because at some point it would have to go. I mean, it might actually go because if the element does not exist, okay, it would just not be able to find and then just go there. So that is where we're gonna use turn -1, and this is to just verify in the function that we did not find the element that you were looking for, or probably this element does not exist in the array if that's what you're looking for. Now we're gonna code this thing up. It'll be pretty simple. We're also gonna take an array and then try to have things up solved as well. Okay, so right. So this is the class. We're gonna have a PSYM. This is in Java, so I'm gonna do a Python version quite soon as well. Public static int binary search. Binary search. I'm gonna need an array. I'm gonna pass. This is the symbol for array, and then I'm gonna pass the target value as well. So this is the target, and I'm just notifying when I say int that this function is going to return an integer. So it's showing me a red line, but now if I were to just return an integer, let's say like a 0, it's going to not show me any red line anymore. But if I were to remove it, it shows me because it is expecting a return type of integer, and it's not going to compile unless I fix this issue. Now, what can I do? I can find the start element, which is going to be 0, and the end element, which is going to be the length of the array -1, right? As I told you, have to look into those indices and then just manually try to understand things. Some of things is something that you can just have to try to understand yourself. And now this has to be the start of the element index has to be lesser than the end of the end index of the array, right? As long as this is true, as we're moving from start to the end, we'll be moving here, here, here. As long as this is true, we're probably we're probably gonna try about finding the middle element and then fastify the process of finding where in the array is this particular element located and get it resolved. So as long as this is true, I'm going to find the middle element. Again, I have to declare the data type unless if you were to do something in Python or so. And now I'm going to do start plus end minus start divided by 2. And I can have an if condition if the array, and I'm going to index this with mid, okay, is equal to the target, then I can just return mid, right? Else if the array of mid is lesser than the target, that means if your target is +1, okay, the other condition is going to be, I can just write else, but so just so that you can understand it, if mid is greater than the target, then that means the target is lesser than this one, so that they have to move towards the left. So the end is going to be end pointer should be moved towards the left side, where you're going to do mid. I hope this sort of thing makes sense, and only in one of these conditions are you going to actually return an integer. But if this were to exit the while loop, you can return -1, and there's not going to be an issue. Okay, because oh wait, as you can see, this thing is really showing me an error still. So this way you can actually try to understand that this compiler is telling you that you're missing something. Okay, let's see if this method should return a type of integer, type int, because you're clearly returning mid over here. But what if this were to come out of the while loop, right? If this were to come out of the while loop, what is the possible case thing that can happen? I mean, you'll have to return something, right? -1. So when is that going to happen if the element does not exist? So that is where you're going to do it. take into consideration. So now I'm going to create an array. I'm going to create an array with some bunch of integers. Go with 2, 4, 6, 10, 14, 16, right? And even 19. And I'm going to show you how this thing is working. And I want to find the target of this, the target element, right? 6 is our target, and I have to find the indice of this. So that's going to be 0, 1, 2. So int answer is going to be BS and array of this thing, and the target is 6. And I'm going to print this answer. So how did I do that? In case if you are working in Java, I did SOUT, and then I entered it, and then I can just type answer, right? So I don't notice any errors so far, apart from this looking red, which I think is how it looks, but I think the color has changed over the time. Okay, everything looks great now. You can just run Java and it has to return. Okay, so fail to reserve memory for increasing overflow, mark capacity inside. This is a new thing for me. Okay, this is not part of the problem. So this is something with my computer. So I'm gonna try to get that resolved. Until then, I'm gonna pause. Okay, so we're back and things are working correctly. And so it's giving us the correct output, which is 2. So what did I do? Honestly, I didn't do anything. I think it was probably my RAM issue because I'm running a lot of things at once. And I just did this again and then it started working. So I think this is something related with memory, and this is something that you can actually look into and explore. Okay, so we found our answer, which is 2, 0, 1, and 2. So, right, that was a little bit of a break, so you can cut that out. So we're gonna debug this sort of process, and we're not just gonna just say, okay, I've understood that particular part. So let's try to understand and debug this one by one. So this is where the function is called and the answer is stored in this particular variable, right? So I'm going to mark this sort of point and I'm going to debug this Java. I have a feeling I might actually get this error because my laptop is lagging a little. Okay, nope, we didn't. And I'm going to step into the sort of function. Okay, now this is the array that we have right now, and this is the target that we're actually looking for. And if I were to go with finding the start index, which is 0, and then the end index, which is 6, and I'm going to see if this while loop condition is satisfied or fulfilled, and then it is, and then I'm going to find the mid element, which is going to be start plus blah blah blah, and that is going to be giving us 3. Again, if you were to notice, you can just do 0 plus 6 divided by 2, and then you get 3. But that is not a good approach, because if the integer size was pretty big, and then there's a high chance that it might overflow, right? So with that being said, this condition checks if the target is equal to if the middle element's target, that means 3, that means 10, is this equivalent to the target, and then return mid. That is not true. So we're going to check another condition, which is if the array of mid, I'm going to index array of mid. Mid is currently 3, and which is 10. If this is lesser than the target, that means the target is 6. Is this lesser than target? Nope. So we're not going to do anything, right? So is this greater than the target? Right? Is this greater than the target? Yes. That means we'll have to move into this sort of direction. Okay, so we'll have to push from here to here. So this is where we're going to move the end pointer, which was over here, to left of the middle variable, to over here, which is middle minus 1 is equal to middle minus 1. So if you were to go a step forward, then you see that end went from being 6 to 3 minus 1, which is 2. Right now, you just have two elements to play with, and you can just try to understand what's going to happen. You find the middle element, which is 1, and if that is equal to the target, is this equal to the target? No, it is not. So you're going to check if that element is lesser than the target. Yes, it is. So that means we'll have to move the start of the element, this one, is this one, to mid plus 1, which is going to be this one, right? Now it's surprising because the start and the end element are the same, which is possible because the middle element is going to be the same as, I'm going to just show you, the start and the end is same. So if you were to do this either way, you would actually end up with the same thing, because the start is 2 and then end minus start is going to be 0. 0 by divided by 2 is also 0. So the start is, you're going to get the same index, right? So all three things is similar, and this is the condition that you actually want to look into at the end of your equation most of the time, right? So is this equal to your target, the middle element, and this is the target? Is this equal to your target? And the element existing in the second index, and is this equal to your target? Yes, it is. So you'd have to return your element or your index, right? And that would be stored in answer, and you're going to print that answer, and that would be 2. Okay, and that was it for today's session, and we'll probably look into it further. And thank you for watching, and love you all.